Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Awangku Haji Muhammad Arief Aieman bin Pengiran Haji Petra. I'm from Faculty of Islamic Technology, enrolling in Bachelor of Islamic Data Science. My index is 25B 1611. Today, I will be presenting my topic entitled Big Data in Everyday Life, Smart Cities. Through this presentation, I will explain how big data enables smart cities to improve transportation, public service, energy management, environmental monitoring, and overall quality of life. In here, the table of content, I provide you why smart cities need big data, source of data in smart cities, data classification in smart cities, the 5 V's in smart cities, data storage in smart cities, data processing in smart cities, big data pipeline architecture, and finally, insights and benefits. First, let's understand why smart cities require big data. As cities continue to grow, they face many challenges such as traffic congestions, rising energy consumption, public safety concerns, and environmental issues. To solve these problems, smart cities use technologies like IoT, sensors, CCTV cameras, communication networks, and smart devices to collect huge amounts of data every second. Big data allows city authorities to analyze this information and make informed decisions instead of relying on assumptions. As a result, cities can improve traffic flow, optimize energy usage, enhance emergency response, and provide better public service. We're going to source of data in smart cities. Big data comes from many different sources throughout the city. First are urban sensors, such as traffic sensors, air quality sensors, weather stations, and waste management sensors. Next are smart utilities, including electricity meters, water meters, and street light systems. We also collect citizens-generated data such as reports submitted through mobile application and feedback from social media. Finally, mobility data comes from GPS systems, public transportation, smart parking systems, and vehicle-to-infrastructure communication. Together, these sources continuously generate valuable information that helps cities operate more efficiently. Next, we are going to data classification in smart cities. The data collected can be divided into three categories. The first one is structured data, which has a fixed format and is stored in relational database. Examples include electricity bills, parking records, and transportation schedules. The second one is semi-structured data, which includes formats such as JSON and XML generated by IoT devices and GPS systems. And finally, the unstructured data, which has no predefined format. For example, includes CCTV videos, image, audio recordings, and social media posts. Since each data type has different characteristics, smart cities use different storage and process methods to manage them effectively. Now we're going to the 5 V's in smart cities. Big data is commonly described using 5 characteristics as the 5 V's. What are the 5 V's? It's volume, velocity, variety, veracity, and value. For volume, refers to the massive amount of data generated every day. So, millions of daily data points from grid, sensors, CCTV, and networks demand massive scalable storage infrastructure. Velocity is the speed at which data is created and processed, especially for real-time application. The immediate sensors response loops are crucial. Adjusting traffic lights signals dynamically requires low latency pipelines. Meanwhile, variety means data comes in many forms, including text, image, video, sensor readings, and GPS information, accommodating everything from simple text, timestamps to video feeds and telemetry coordinates simultaneously. For veracity, it's focused on the accuracy and reliability of data because of poor quality data can lead to incorrect decisions. Decisions makers rely on accurate, verified data to avoid catastrophic grid failures or emergency response. And finally, value is the ultimate goal, where raw data is transformed into useful insight that improves city service and decision making. The core objective of raw telemetry collection on transforming chaos into real-world citizens' safety and cost efficiency. And we are going to data storage in smart cities. Because smart cities generate enormous amounts of information, efficient storage systems are essential. Large multimedia files such as CCTV recordings are usually stored as files. Structured information like utility bills and transportation records is stored in relational databases. Meanwhile, semi-structured and unstructured data are commonly stored in NoSQL, databases because they offer greater flexibility. Cloud storage is also widely used because it provides scalable, reliable, and cost-effective storage and large datasets. Together, these technologies ensure that city data remains accessible and secure. After this, that we are going to data processing in smart cities. After storing the data, it must be processed to produce useful information. These are two main processing methods. The first one is batch processing. Batch processing analyzes data collected over a period of time, making it suitable for identifying long-term trends such as electricity consumption or traffic patterns. The second one is real-time processing. Analyzes data immediately after it is generated. This is important for applications like traffic signal, control, and emergency response. Technologies such as Aspect Park and Apex Flink are commonly used because they can process large volume of data quickly and efficiently. And then we are going to big data pipeline architecture. The first stage, and then we are going to big data pipeline architecture. This slide shows the overall big data architecture in use in smart cities. The process begins with the data sources layer, where two IoT devices, sensors, cameras, and smart meters continuously collect information. Next is storage layer, where data is stored in relational databases, NoSQL databases, cloud storage, or distributed file system. The third one, the process layer, then cleans. The third one, the processing layer, then cleans, filter, analyzes, and transform the raw data using big data technologies and AI algorithms. And finally, the visualization layer presents the results through dashboards, graph, and reports that help decision makers monitor city conditions and take appropriate actions. And finally, we're going to insights and benefits. Big data provides many important benefits for smart cities. It improves traffic management by identifying congestion and optimizing traffic signals. It helps utility companies reduce electricity and water waste through better resource management. Environmental monitoring system detect pollution levels and support sustainability initiatives. Public safety is also enhanced through predictive analytics and faster emergency response. However, smart cities also face several challenges. This includes protecting citizens' privacy. We need to have amanat. We need to defend against cybersecurity threats, integrating different technologies, and managing the high cost of implementation. Therefore, strong governance and responsible data management are essential. To conclude, big data plays a vital role in the development of smart cities. By collecting, storing, processing, analyzing a large amount of urban data, cities can improve transportation, energy management, environmental sustainability, and public service. Although challenges such as privacy and cybersecurity still exist, the benefits of big data far outweigh these issues when managed responsibly. As technology continues to advance, big data will remain one of the key foundations for building smarter and more sustainable cities. That concludes my presentation. I appreciate for the time and attention. If you have any question, I will be happy to answer them. I left my phone number and my official Unicef email. If any further inquiries, I will be gladly to answer them. However, I hope there's none. Thank you.